Sito-Tree is an open-source library for hierarchical data visualization. The library shows JSON data as nodes of a tree. You can read arbitrary data, and its hierarchy will be shown as graph or tree, using a custom mapping schema. The library allows for interactive nodes creation or merging. You can export the underlying data structure in every moment. There are lots of different events you can register callbacks on, like node click, edge click, node dragging, node merging, and so on. The graphical properties are customizable: node size, stroke weights, font size, and so on. Node's color can be assigned randomly, and be fixed for all the elements that belong to a tree, or it can depend on a given internal property for the node's underlying data. Here, in this very ugly page, you can see some examples. In the first example, you have an interactive empty tree. Click on the white canvas to create a node. Drag a node on top of another to append the node as child. This will create a tree. Double-click on a node to expand its children. Move the mouse on an edge to see how it's highlighted and click on it to select. If you open the console, you can see some registered logging callbacks. The second example shows a read-only tree, representing some JSON data. You can move the nodes around, expand and collapse a given node or all the trees. If you click on the Update button, you will see how some node colors change. That's because while in the first example, the node's color depends on the tree they belong to, in this example the color is given using an internal property in the read JSON data. If the property changes, when you click Update, the color changes too. Third examples show how to create a read-only tree from JSON data that has an row-first layout. Fourth example is the same, but using a column-first layout. The fifth example shows a graph created by reading some JSON data. The schema, used to map the data to the nodes, is shown in the middle. This tree is interactive, so you can create new nodes by clicking on the canvas, merge them, and you will see how the underlying data is changed accordingly. In the bottom panel in the middle, you can see the payload attached to the selected node. The last example is like the previous, but this time we registered a callback on the edge selection, to show, in the bottom middle panel, what edge you are clicking on.